As you can see, I've already shown all of my working out for this question, but I'll just talk you through it. So for part A, proving the identity, I'm looking at both sides and deciding which side to start on. I've decided to start on the left-hand side because I can see that there's clearly more things for me to do there. I've got the tan theta and I've got the cot theta. I know I can rewrite both of those. Then I can add them together. Whereas on the right-hand side, I've got the cosec, which there's not a huge amount I can do with that. So starting on the left-hand side, I've got the tan, and I know I can rewrite that as sine over cos. And then I've got the cot. Now, I could write cot as 1 over tan, but I've instead decided to write it as cos over sine. That way, it's going to make it easier for me to combine it with the sine over cos and get me closer to this cosec 2 theta. My next step was to get a common denominator. So I've multiplied the first fraction by sine theta, and I've multiplied the second fraction by cos theta. Now we've got a common denominator of sine theta times cos theta, which I've got here. On the top, we've got the sine squared plus the cos squared. And we know that sine squared plus cos squared is just 1. So we're now at this stage here where we've got 1 over sine theta cos theta. That sine theta cos theta on the bottom there, I'm noticing that that's quite similar to the sine double angle. And I want to end up with a double angle. I can see that from my result here. I want to end up with the cosec 2 theta. So I want to be able to rewrite this with a double angle. So what I've decided to do is I've decided to times the bottom by 2 and the top by 2. That way, this denominator is now exactly the same as sine 2 theta. And then I can move that sine 2 theta and think of that, because I can think of this as being 2 times 1 over sine 2 theta. And then this 1 over sine 2 theta is the same thing as cosec 2 theta. And that's what we needed to prove. So we've done part A. Part B. It says hence, so we're going to use what we've just done. And I'm comparing this equation to what we just did in part A. So I'm comparing this and what I've got up here. And I notice that it's exactly the same as what I've got on the left-hand side, which means that I can identically just write down that it's going to be 2 cosec 2 theta. So that's what I've done. I've replaced the tan theta plus cot theta with 2 cosec 2 theta and made that equal to 4. I've divided both sides by 2. I know that cosec is 1 over sine, so I've done the reciprocal to get sine. The reciprocal of 2 is 1 over 2. So I now know that sine 2 theta needs to be equal to 1/2. I've done sine inverse of 1/2, which I know the first answer to that's going to be pi over 6. Use your calculator if you wish. And then I'm going to use the graph and find lots of solutions. I know I need to find twice as many solutions as I normally would, because in a minute I'm going to divide everything by 2. So that's why I've drawn my graph twice as big as you might expect. You might expect me to only draw the graph up to 2 pi, but I've drawn it all the way up to 4 pi. I know this is pi over 6, so this is going to be pi minus pi over 6, which is the 5 pi over 6. This is going to be 2 pi plus pi over 6, which is the 13 pi over 6. And this is going to be 3 pi minus pi over 6, which is the 17 pi over 6. And then right at the end, I've just divided everything by 2. So these are my 4 solutions.